Hello everyone. So today's topic is storage and querying in DBMS. So the top syllabus are storage and file structure, indexed files, single level and multi-level indexes, query processing, and query optimization. So the overview of the physical storage structure. So a database system provides an ultimate view of the storage database. However, data in the form of bytes gets stored in different storage devices. So the main three types of data storage are primary memory, secondary storage, and tertiary storage. So first is the primary storage. The storage that is directly accessible to the CPU comes under this category. The CPU's internal memory, fast memory, and main memory. Second type of data storage is secondary storage. Secondary storage includes memory devices that are not a part of the CPU chipset or the motherboard. So some of these are magnetic disk, hard disk, and flash drives. The third type of storage is tertiary storage. It is used to store huge volume of data. Since such storage devices are external to the computer system, they are slow in speed. So some of the examples are DVD, CD, etc., magnetic tapes as well. So moving forward, we will see the overview of the physical storage device. So talking about cache, the cache is the fastest and most costly form of storage. Cache memory is small, it is used in managed by the computer system hardware. Second is the main memory, the storage medium used for data that are available to the operator and is the main memory. The general purpose machine instruction operates on main memory. Although the main memory may contain many megabytes of data or even gigabytes of data, in large server system, it is generally too slow and also it is too expensive for storing the entire database. So the next is flash memory, which is also known as electrically erasable programmable read-only memory, EEPROM. Flash drive memory differs from main memory in the data surveillance power failure. Reading data from flash memory takes less than 10 nanoseconds. So just for telling that a nanosecond is 1 by 1000 of a microsecond, which is roughly as fast as reading data from the main memory. However, writing data to flash memory is more complicated. Data can be written once, which takes about 4 to 10 microseconds, but cannot be overwritten directly. To overwrite memory that has been written already, we have to erase an entire bank of memory at once. It is then read to be write again. A drawback of flashback memory is that it can support only a limited number of erase cycles, ranging from 10,000 to 1 million. The flashback memory, also found popularly as replacement for the magnetic disk for storing small volumes of data like 5 to 10 megabytes in low-cost computer systems. Next is the magnetic disk storage. The primary medium for the long-term online storage of data is the magnetic disk. Usually the entire database is stored on magnetic disk. The system must move the database from disk to main memory so that they can be accessed. After the system has performed designed operations, the data that have been modified must be written to disk. So the next is optical storage. The most popular form of optical storage is the compact disc, also called as CD, which can be hold about 640 megabytes of data, and a digital video disc, which is called DVD, which can hold up to 4.7 to 8.5 gigabytes of data per side of the disc. Data are stored optically on the disc and are ready to be lasered. Next is tape storage. Tape storage is usually primary for backup and archival data. Although magnetic tape is much cheaper than the disk, access to the data is much slower because the tape must be accessed sequentially from the beginning. For that reason, tape storage is referred as sequential access storage. In contrast, disk storage is referred to as direct access storage because it is possible to read data from any location on the disk. So the tapes have a high capacity which ranges from 40 gigabytes to 300 gigabytes and can be removed from the tape drive. So they are well suited to cheap archival storage. So the next topic is RAID, redundant array of independent disks. RAID or redundant array of independent disks is a technology to connect multiple secondary storage devices and use them as a single storage medium. RAID consists of an array of disks in which multiple disks are connected together to achieve different goals. RAID level defines the use of disk array. So talking more about RAID, it consists of 7 levels. Level do not imply a hierarchy relation but different design architectures that share 3 common characteristics. First, set of physical disk drives viewed by the operating system as a single logical drive. Data are distributed across the physical drives of an array in a schema known as stripping. Third, redundant disk capacity is used to store partial information which guarantees data recovery in the case of disk failure. So these are the levels of the RAID. So we can see here that category, level, description, disk requirement, data ability, large input output data transfer capacity, and small input output request rate is given. So you can refer this. So moving on, so we'll talk about database management system. So DBMS is a software that allows to access data stored in database and provides an easy and effective method to define the information, store the information, manipulate the information, protect the information from system crash or data thefts, differentiating access permission from different users. So DBMS acts as an interface between users and the database. The user requests the DBMS to perform various operations such as insert, delete, update, retrieval, and others. So in database, system structure is partitioned into modules for different functions. So some functions like file system may be provided by the operating system. The database system is divided into 2 functional components: query processing and storage manager. So this is the architecture of database system structure. So in this we can see that how it is how the structure is of the database system. So talking about it, the user issues a queries using a particular database language like SQL. The query processor processes the queries or programs with the help of its components. The storage manager accesses the stored data from the disk, and DBMS returns the results to the user. So moving forward, we'll talk about query processors. Query processors helps the database system simplify and facilitate access to data. The work of query processor is to execute the query successfully. It interprets the request received from the end user via an application program into instructions. It also executes the user request which is received from the DML compiler. So talking about the query processor components, first is a DDL interpreter. It interprets the DDL statements like schema definition into set of tables containing metadata and stored in the data dictionary. DML compiler. It translates the DML statements like select, insert, delete, update into low-level instructions so that they can be executed. A query can usually be translated into any of the numbers of alternative evaluations plans that all give the same result. The DML compiler also performs query optimization. That is, it picks the lowest cost evaluation plan from amongst all the alternatives. The query optimization determines the efficient way to execute a query with different possible query plans. Next is embedded DML precompiler. It processes DML statements embedded in an application program into procedural calls. Next is query evaluation engine. It executes the low-level instructions like object code generated by the DML compiler. So second is the storage manager. Storage manager is the program that provides an interface between the data stored in database and the queries received. The storage manager is responsible for the interaction with the file manager. The raw data are stored on the disk using the file system, which is usually provided by the conventional operating system. The storage manager translates the various DML statements into low-level file system commands. This is responsible for updating, storing, deleting, and retrieving data in the database. It is also known as the database control system. It maintains the consistency and integrity of the database by applying constraints and execute the DCL commands. Next is the authorizing manager and integrity manager. It checks the authority of the users to access data and checks the integrity constraints when the database is modified. Next is transaction management. It ensures that the database remains in a consistent state despite system failures and the concurrent transaction executes proceed without any conflict. Next is a file manager. It manages all the allocation of space of disk storage and the data structure used to represent information stored on disk. Buffer manager. It is responsible for fetching data from the disk storage in main memory and deciding what data to cache in main memory. So we'll move forward. We'll talk about file structures. The file is a collection of records. Using the primary key can access the records. The type of frequency of access can be determined by the type of file organization which was used for a given set of records. File organization is a logical relationship amongst various records. This method defines how files records and are manipulated on the disk blocks. File organization is used to describe the way in which the records are stored in terms of blocks and the blocks are based on the storage medium. That's it for this video. Thank you.